welcome back to School of Experiments. Today I would like to explain you regarding the Ohm's law. There was a scientist in Germany and his name was George Ohm. That means his surname is Ohm. I mean last name is Ohm, and then based on that surname the law has been created. Basically this law talks about voltages and current. Voltage is nothing but a potential difference between has a positive and battery has a negative. So if you measure the voltage, the potential difference is known as the voltage. Like that, how much electricity it is giving out is known as the current. So today we will conduct an experiment to to find out what exactly Ohm's law states. The Ohm's law basically states that the current is directly proportional to voltage, whereas R being the constant, whereas R means a resistance. C is one form of energy. Electricity is one form of energy, like wind energy, like water energy, and we have. I mean to say, suppose a water is flowing, water current is there, a river of water is flowing, then there are currents. That means the water is flowing from a higher level to a lower level in a river. Like that, the wind is flowing from a high pressure area to a low pressure area. Likewise, our electricity will also flow from one high area to low area. What is that area? We will see. For example, there is a battery. Okay, there is a positive and there is negative. So when the electricity has to flow from this portion to this place, then a circuit, what you call it as a circuit, should be complete. Then only the electricity will flow from positive to negative side. So, but what is the capacity of flowing from here to here is known as the potential difference. Unless there is a potential difference, suppose if you put a voltmeter here, then you will find the potential difference basically there. And the amount of energy that has passed is known as the current. That means if you take a tank of water, let us say, okay, so if you put a hole here, the with what force the water is coming out can be considered as potential difference. This force is nothing but a potential difference. Okay, what do you call it as? V. Okay, and how, suppose this water level has reduced to some lower level. Okay, then automatically this will also reduce. That means the amount of water that is inside is known as the current, what you known as I. Okay, so now we are trying to establish what is the relation between the current and the potential difference. Nothing, we will measure it in terms of volts. Okay, so as per Ohm's law, the current is directly proportional to voltage. The I is directly proportional to voltage, or in other words, voltage is directly proportional to current. Okay, this current, now if you want to make it equal, then there must be some constant should come into picture, multiplied by I should give the value of the voltage. This constant now known as the resistance. We will see what is resistance now. Supposing there is a conductor. Okay, electricity is passing from this conductor. These conductors can be mostly metals, maybe copper, silver, aluminum. These three are the most popular conductors good conductors of electricity. Okay, from this point to this point the electricity is passing, which is known as a conductor. Supposing if I want to have a obstruction here, okay, for example, the voltage given here this side is 20 volts. Okay, because of this resistance, it offers some resistance which is known as, in in electronics language, it's known as a semiconductor. That means it will allow the current partially to this side. So that means, let us say we got 10 volts this side. So if you measure, this should be connected to a battery. A battery symbol is known as like this. This is positive side, this is negative side. Okay, and this is connected to, let us say, voltmeter. Okay, this is voltmeter. Okay, this is what you call it as cell or a battery or any source of electricity, in other words. So this resistor now is connected or in series. That means to this battery, one positive is connected to one side and negative is connected to one side. This is what is known as a series connection. There only a circuit can close. Okay, we will discuss about parallel connections in the next class. So this law, if this is the circuit, then our Ohm's law, when what is stated, voltage is proportional to I, should be satisfied. This is, I have made a a circuit exactly like this, and I will conduct the experiment and we will put a graph, and then we will see how the results will record it and how we are going to prove the voltage is proportional to current as per Ohm's law. I will show you the circuit.
Okay, today I want to show you the circuit diagram for Ohm's law. So this is the circuit diagram I'm talking about, and this represents one battery, and this represents another battery, and this represents one more battery, which is three batteries in series. And now this battery is connected to through this wire to a multimeter, which I am using it as a ammeter, which set to 20 milliamps current, which I can measure here. And this is connected to this wire, and this wire is connected to a resistance here. So this resistance value as per the color code is 2.2k, that means 1200 ohms, and this is the other end is connected to the battery here. Okay, now we will I have also connected two wires here, for which they are connected to another multimeter, which I am using it as a voltmeter here, and it is set for measuring the voltage, if you look at here. Okay, now I will connect this ammeter to one battery here, and we will see it measures 1.59 volts for this battery, and the measurement of the current is 0.73, which we will record onto the graph. I have drawn a graph here measuring volts onto the y-axis, you see, and then the current on the x-axis, which I divided into 0.5, 1, 1.5, 2, 2.5, and 3 milliamps, and the y-axis I divided 1, 2, 3, and 4 volts basically. And now we want to prove that the voltage is proportional to current. Measure with one battery now, and let us see how much voltage it takes up. So it has taken up 1.59 volts and 0.73 amps. Let us mark this on the graph. Okay, so 1.5 means somewhere more than here, more than half, and zero point 0.7 somewhere here. So this comes to somewhere here, matching point, and this point is 1.59 volts and 0.73 amps. Okay, so we'll increase the voltage to two batteries and see. It is measuring 3.17 and it is measuring 1.45. So we will record this again here. So 1.45 amps is somewhere here, and the 3.17 volts is somewhere here. So I have identified one more point here. Okay, and then I will measure with three batteries now. That means I will have more voltage here, and which we will measure. Okay, so with three batteries, it is showing 4.75 volts and 2.17 as the current. So 2.17 somewhere comes here, and I have measured the point here. 4.75 comes somewhere still higher, of course. Okay, so this is the another point I got. Point. If you draw a graph, it will pass through all these points. Okay, which shows that uh, the voltage is proportional to current. So this straight line indicates the proportionality. Now if you want to establish a relation between the voltage and the current, it should have multiplied by a constant, what is called R, a resistance. Now using these calculations, we will find out the resistance. For example, in this case, 1.59 volt is 1.59 is equal to R into current is 0.73 milliamps. Sorry, this is not amps, milliamps, milliamps, milliamps. Okay, milliamps. So now resistance is equal to 1.59 divided by 0.73 milliamps, which should come to 2148.32 ohms, which is equal to approximately 2002 kilo ohms. That is what the resistance what we used. Hope you understood the Ohm's law correctly, and then we'll meet in the next class.